Okay, so we are going to be carrying on talking about scaling, but this time we're also going to be looking at area, how those are related to each other. So our first question says, on the grid, draw a scaled copy of polygon Q using a scale factor of 2. Then compare the perimeter and the area. Compare the perimeter and the area. Okay, so first we're going to draw a scale factor of 2. So a scale factor of 2 means that every side gets multiplied by 2. Remember, factor means we multiply. So I'm actually going to start this, I think, up here in this corner because, and corresponding with this point here in this corner, because I don't know how big of an area I'm going to need. So let's start with probably, I think, the top here, okay? So we're going to count the top 1, 2, 3, 4, 5, 6. So I know if that's 6 times 2, that's going to equal 12. So that means my new side up top is going to be 12. So I'm going to count from my point here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now remember, I'm counting these lines here. So that's going to go right there, right? And I'm going to draw a line straight across. And I'm actually also going to label that as being 12, because remember, we have to find the perimeter afterwards. Okay, so if I follow this right along here, and I can see that this is 1, and this is also 1. So I know that 2 times 1 is going to be 2. So I'm going to go down 2 to here, and then to the left 2 to here. So let's make both of those lines. Yep, I don't know why I'm having such a hard time making this straight. It's very silly, huh? Oh, that one will work. Okay, next we have this side right here, which is 2. And 2 times 2 is going to be 4. So now I'm going to be going straight down 4 from this point here. I'm going to go 1, 2, 3, 4. So I'm going to put another point right there. Remember, it's easier just to draw these points and then use, the straight edge of an index card, I know we've been doing, or a ruler, or whatever you have, to make sure that the lines are nice and straight. Especially these ones that are a lot longer than, the other ones. Those can be a little bit more difficult to make sure that they're exactly straight the way that we want them. So next we have, down the bottom here, 1, 2, 3. So that's 3 times 2 is 6. So our new line across is going to be 6. I've got 1, 2, 3, 4, 5, 6. So I'm going to put my next point right there. Then again, we've got another one. That's 1 right there. So that would be 1 times 2. Of course, is 2. So it's going to be this point right here. Then my next one going across here, about 1, 2, 3, 4. So 4 times 2 equals 8. So if I did this correctly, these last two this should line up with it wherever this one's going to end up. So let's count 1, 2, 3, 4, 5, 6, 7, 8. And it looks like it lands perfectly, just like it should, right here. And then I know this last side over here is 2 times 2, which is equal to 4. And I can see that that is exactly 4, just the way it should be. We'll drop this here, and then we go right across with the 8. Now, I am going to go back and label them. I did say to label them, and then I forgot as they went around. Okay, so if I'm going to add these up, now remember, we can add in groups just to make things easier for us. So in other words, I've got 8 plus 2 I know is 10. And then I know that 6 plus 4 is also 10. And then if I include my 2, 4, and 4, that's 8 plus 12. 8 plus 12, of course, is 20. So then my new perimeter of Q would be 20 plus 20, 20 plus 10 plus 10, and that, of course, is 40. And if I look at my old one, my original, I should say, not my old one, and I look at the sides around here, I had 6 plus 1 and 1 is 8, plus 2 is my first 10 right there, so that's 10. Then if I continue around to my other sides, I've got 3 plus 1 is 4, plus another 4 is 8, plus 2 is 10 more. So the perimeter of the original was 10 plus 10, which is 20. And as it would be expected, it's double. 20 times 2, of course, is equal to 40. So my perimeter doubles. And remember, that's exactly what we expect it to do every single time. The perimeter doubles. Okay, so let's take a look at let's think about the rule that we learned in this, this last lesson, that when we use a scale factor, as far as the area goes, we take that scale factor, which is 2, and it gets squared, or raised to the second power. We know that means 2 times 2, which is 4. So we would expect the original area, original area to scale by 4. In other words, be multiplied times 4. So let's take a look at this and see what we got going on here. So if we take our original figure, if we just go ahead and count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that means our original is 14, not 14, 16. I had the 4 in my head. And I multiply that times 4. That means my new area, I'm going to think up here in my head, I'll be thinking 10 times 4 is 40, right? And then 6 times 4, that's a 6, equals 24. And then 40 plus 24, of course, is 64. So my new area should be 64. So if I wanted, just to double check, just so that you can really see this happen, I'm actually going to take my rectangle, my copy, and just divide it into pieces so it's easier to see. Let's count these up. I've got this upper left-hand corner here. I've got 1, 2, 3, 4, 5, 6, 7, 8. So this area right here is 8. Then in the all the way far to the right, I've got 1, 2, 3, 4, 6, 7, 8. 1, 2, 3, 4. 8 by 4 is 32. You can count those if you'd like, but I'm just going to go by how we know to find area. But this is a compound shape, so it's a little bit different. My last rectangle down here, I've got 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4. 6 times 4 is 24. And if I add 24 plus 8 plus 32, well, I know 8 plus 32 is 40, plus 24 more, that in fact is my 64, like I would expect it to be. Now I know this got a little messy from the layering of each part, so you might want to rewind this so you can see each part a little bit more separately. Okay, next. And the right triangle has an area of 36 square units. If you draw scaled copies of this triangle using the scale factors, what will the areas of these scaled copies be? Explain or show your reasoning. Now, of course, you can use some graph paper and you can draw them, but we don't have to. We know the rule now. Like this one right here is 36, the scale factor. We take that 1. Actually, I'm going to use a darker color because I'm on the white. Let's use. So I got the 1. I know that the 1 is going to be squared, which equals 1. And then I take the 1, I multiply it times 36, the original, and I get 36, right? So it should work every single time. So I'm going to take my 2. I'm going to do 2 squared, which means 2 times 2, which is 4. And then 4 times 36 equals, well, 4 times 30 is 120. 4 times 6 is 24. 120 plus 24 is 144. I really hope you're taking the time to listen to how I talk these through, because this is how people who are good at math become better at math. So eventually, I would hope that you're going to start talking these through just like I am. So my next one, I've got 3 squared. That means 3 times 3, which is 9. Then 9 times 36 equals, okay, 9 times 30 is, of course, 270. 9 times 6 is 54. 270 plus 50 is 320, plus the 4 more is 324. Okay, I've got 5 now. So 5, I'm going to square 5. So I've got 5 squared, which is equal to 5 times 5, which is 25. And then I've got 25 times 36. I'm going to actually do this over here in the corner so you can follow me. I always like to think about 25 as quarters. It's just what makes sense. Because quarters, I know that 4 quarters makes $1, or that 4 times 25 equals 100, right? So I want to think to myself, how many 4s are in 30? Well, 4 goes into 30 7 times, right? 7 times 4 is 28. I hope you're with me. If you're not listening, you're going to get confused. Be sure to come and ask me if this becomes confusing for you. So 7 times 4. So remember, 4 times 25 gave me 100 every time. So if I've got 7 sets of 4, that's going to be 700. Okay? And then I still have 2 more 25s. So that's plus 50 more is 750. So that takes care of the 30. But now I still need to take care of the rest, the 6. 25 times 6. Well, that's kind of hard to read. Sorry about that. 25 times 6. Again, think about those as quarters. If I had 6 quarters, that would be $1.50 or 150. Then I add my 750 plus my 150. 700 plus 100 is 800. 50 plus 50 is another 100. So that means 25 times 36 is going to give me 900. Now, I'm very aware that you can use a calculator to do this, and probably you're tempted to. But if you're going to use a calculator, I would use it to check your work, not to just do your work, so that you can have better number sense. So now I've got 1/2, so it's a fraction. What happens when I multiply a number by a fraction? Remember, it gets smaller. Now I'm going to even make this fraction times a fraction, so it's going to get even smaller. So 1/2 times 1/2, that's my 1/2 squared. So I do my numerator squared. Remember, top with the top and the bottom with the bottom. So 1 times 1 is 1, and 2 times 2 is 4. So now I've got 1/4 times 36. If I'm going to multiply these, I need to make that into a whole number, put it over 1, right? And then the top with the top and the bottom with the bottom. 1 times 36 is 36. 4 times 1 is 4. 36 divided by 4 is 9. And my last one, I've got 2/3 now. So it's the same process. 2/3 squared. So 2/3 times 2/3, top with the top and the bottom with the bottom. It's so fun to say. 2 times 2 is 4. 3 times 3 is 9. Don't get confused that we're multiplying times 2. We're squaring those. So now I've got 4/9, and I'm going to multiply that times 36. Right? And that gives me the top with the top and the bottom with the bottom. Okay, now if we remember correctly, remember we did a 4 times 36. Remember doing that? I remember doing that. So we know that 4 times 36 is 144. 9 times 1 is 9. How many times does 9 go into 144? Well, 9 goes into 14, I know, 1 time, with 5 left over. So that's 54. 9 goes into 54 16 times. The last one is 16. Isn't this fun? Okay, here's an unlabeled polygon, along with its scaled copies, polygons A through D. For each copy, determine the scale factor. Oh, well, this is like basically review. So the easiest thing to take notice of is this side right here, because it goes right along, right on the line, and it's 2 whole units, right? So I know that when I go to A, it's 1. So for A, well, first of all, let's remember to find the scale factor, we divide, right? To find scale factor, because I know some of you are still confused about this for some crazy reason. Scale factor. Okay. I don't know why I'm having such a hard time writing tonight. It's silly. Scale factor is equal to the copy divided by the original. And it has to be in that order every single time, the copy divided by the original. So if you have not memorized that, it's time to. So here we go. We'll look at A. Whoops. Not the highlighter anymore. Okay, so for shape A, the first copy, I already noticed that it's 1. So my copy is 1 divided by the original, that's 2. So the new one is, of course, 1/2. Right? Next is B. Let's see what we have here for B. So if I look at this, my new one is 4, right? So I've got my copy which is 4, divided by my original, which is 2. 4 divided by 2 is 2. Next is C. If I look at my copy, it's 3. And I know that I have to divide my copy, which is 3, divided by the original 2. You can leave it right like that. It's 3/2. I know some of you are desperate to make that 1.5. It's fine, either one, when we're using scale factor. Both work. And then I've got D. My copy in D is 2. So 2 divided by 2 is equal to 1. Now I know that some of you are very tempted to say it's the same size, but that doesn't tell us what the scale factor is. The scale factor is always the number we multiply by. So if it's the same, we know that we multiply by 1, keep something the same. Solve each equation mentally. Oh, this is fun. Okay, if you remember correctly, we always do the opposite. The opposite. When we're solving any kind of equations, we always do the opposite. So, for these first two, I'm multiplying. So that means that the opposite is to divide. So that means, I'm going to bring this right over here, that means that x is going to equal 1 divided by 1/7. Ah, Mrs. De Silva, that's so scary looking. No, it's not. It's just a simple division problem. Remember, it's 1 divided by 1/7, right? Math Macarena. First we will divide. Keep the first, flip the second, then we multiply. Keep the top with the top and the bottom with the bottom. Got a whole number? I mean, this should be fairly obvious that it's 1 times 7 is equal to 7. Okay? So for A, x equals 7. And I know it seems like a little thing, but you really should leave the x in there telling me x equals 7. Okay? Next, B. X times, well, I know the opposite of multiplying is dividing. So I am going to divide 1 divided by 1/11. Mrs. De Silva, that's so scary. I don't know what to do. No. It's fun, folks. It's fun. 1 divided by 1/11. Did you already forget that fractions are our friends? I hope not. Keep the first, flip the second, then we multiply. Keep the first, flip the second, then we multiply. Keep the top with the top and the bottom with the bottom. There it is. So that means for B, x equals 11. Hopefully you're seeing some patterns here and that emerge, but it is important, if you don't especially, that you see it. Oh, that didn't make that better. I don't like that at all. Let's try this one. Oh, that's better. Okay, next and last, I've got 1 divided by 1/5 equals x. This is just like the ones we were doing up top. Easy peasy. So I've got 1, whoops, I did that every time. 1 divided by 1/5, right? I just simply copied it. We didn't even have to look at it as a complex fraction, even though those are so fun. So, keep the first, flip the second, then we multiply. Keep the top with the top and the bottom with the bottom. Lastly, we reduce. So that means for C, that x equals 5. Woohoo! So fun. That's it.